Hey guys, it is Whine here with Memphis Communiversity, and today we will be talking about optimization. So instead of just diving into the worksheet, I'm actually going to start by writing out some steps, excuse me, on a second sheet, and then explaining it all on the front end, so hopefully the worksheet will be a little bit easier. So, the first thing you need to know about optimization is that there are two different functions involved in the problem. Firstly, there's a constraint. So optimization is really just a system of equations that you have to identify the equations in. And the first equation is the constraint, and we use that to make the second function, which I'm about to describe, into one variable. The second function is the function that is actually being minimized or maximized. So the constraint is really just a way for us to solve the second equation, and the second equation is the equation that we will be answering questions about and actually solving and find the absolute min or max sub and stuff. So it's the more important one for sure. Okay, steps to solving optimization questions. Really it's just kind of, I called it sub-zero because it's not implied, but you definitely have to identify the functions first, identify both the constraint and the function that's being minimized or maximized in the equation. So that's step one, or step zero. Step one is making sure that the second function uses only one variable by using the constraint. So we just isolate one of the variables in the constraint. They use the same variables, and then we substitute that equivalent into the function so that the function only has one variable, and therefore we can solve for it. Sounds really complicated now. I promise I will explain it better, and you will see it when we are actually doing the equations. It's not that bad. Step number 2 is to take the derivative of the second function and solve for 0. See, I just learned that I can move myself instead of having to move the video. So now you can read it. Okay. So as I said, the second part is pretty straightforward. Most of the derivatives are not too bad. These equations are not terrible. Step number 3 is to draw the sign chart of the zeros. In this video, I'm not really going to go diving into sign charts and how to do them. There's a whole nother video about that you guys can check out. So I'm just kind of going to draw them, maybe a brief explanation as to why, but I'm not going to go way into depth. So check out that other video if you don't know what I'm talking about when I say a sign chart, or if you get confused in the worksheet while I'm working through it. Cool. Okay. So, this is just a little reminder. A positive slope in the sign chart means it's an absolute minimum, and a negative slope in the sign chart means it's an absolute maximum. And those are the things you're going to be searching for in these questions. So it should work out the right way. It should be a minimum if it's asking you to minimize something. So usually you can know that from the problem, but just a reminder. And I don't know, the way I always remember, oh, sorry, it's blurry. Oh gosh. Okay, it's just going to be blurry. Okay, the way I always remember this, how I remembered what was what, is, so an absolute minimum goes from negative to positive, which is exactly what a positive slope does on the sign chart, and vice versa. The absolute minimum goes from positive to negative on the sign chart, which is what the line does on, or in reality, in the function, it makes a little parabola. It goes negative, or positive to negative, and in a straight line on the sign chart, that's how the negative slope looks. So that's how I always remembered it. I even kind of drew it on my worksheets. Just helped me remember which was which. But like I said, you should be able to identify and look for and know what you're looking for in the problem, and they should line up if you do everything right. Moving on. Number 4 is to justify that the 0 is a minimum or a maximum, depending on what you're looking on, by using the sign chart. For AP Calculus students, this is known as the first derivative test for the absolute minimum or maximum. So on every question, we're going to write out this really long, annoying sentence justifying that it's a minimum or maximum. This sentence does not actually answer the questions it asked, but on the AP exam, you're going to have to know that sentence and how to write it out. It's not super exciting, but that's kind of what AP questions will be testing, so you need to know how to do it. Yes. Okay, so we're fixing to start the worksheet, and just a little heads up, on the worksheet, I actually kind of do a step 5 that I didn't write in. Step 5 is actually solving what the question is asking for. Sometimes the question is asking you to solve for the 2 variables that are in the 2 functions, and you just have to remember to go back and actually answer the question. Like, for example, question 1 is finding 2 numbers. You have to actually go find those 2 numbers. You can't just find the 1, 0 that is an absolute minimum or maximum. So just a heads up for that. So I'm just going to write out my steps and start solving these problems. Okay. So for number 1, 0, identifying the 2 functions. So a constraint typically looks like whose difference is 50, whose sum is 45, whose product is 27. Things like that. Those are, a constraint actually has a number in it, as opposed to the second function, which you'll see in a second. But the constraint is usually one that has a number in it. So in this case, x minus y equals 50, whose difference is 50. And then the second function, whose product is a minimum, you just know that this function is xy. It's not set to anything. We don't know what it's equal to. That's just the function. Step 1, as you guys hopefully remember, and as I hopefully remember, is to make the second function only one variable. As you can see, they both involve xy. They both involve the same variable. So we will just isolate. I always isolate x, but I mean, you don't have to. I always isolate y to solve for x, excuse me. But you don't have to. You isolate one of the variables and then just plug that into your second function, which in this case is p of x for me because it's a product. And then what you really want to do is write it in a form that's easiest to take the derivative of. So I distributed out that x to make x squared minus 50x. Because as you guys remember, step 2 is taking the derivative of the second function, in this case p of x. Like I said, a lot of them are super easy derivatives. And remember, you have to set it equal to 0. Remember to always write that set equal to 0 so that your grader, if it's an AP exam, the AP graders, or you're just your math teacher or math professor in college knows what you're doing. And then you solve for x. Usually the equations are not too bad. So in this case, we know that x is, the 0 is 25. And like I said, I'm not going to really delve into sign charts and explanations of all of them, but in this case, I'll give a brief explanation. Okay, I said I was going to give a brief explanation, but then I got confused on what the explanation was, but now I understand it, and so I'm going to explain it. So, like I said, this p prime of x equation was pretty easy. It's actually a linear equation. You can make it y equals mx plus b. And in this case, the slope too is positive, so this line is going to be a positive slope. So that's how it works in this case. There are going to be other justifications for other things. Like I said, check out the sign charts video if you're confused. Okay, number 4 is where we get that really annoying sentence that I was talking about earlier. It's very formulaic, you just have to know how to write it. So what this sentence basically is saying is, on one side of the 0, it's positive or negative, and on the other side of the 0, so if on one side of the 0 it's negative, then on the other one it's positive. And because you know both of these things, then this has to be the absolute minimum or maximum. Is what this sentence is basically saying. So in this case, if I can write it out faster. Okay, so in this case, the sentence is, because p prime of x is less than 0 for x is less than 25, and p prime of 0 is greater than 0 for x is greater than 25, p of x will have an absolute minimum at x equals 25. Remember, this is a positive slope, so it goes from negative to positive, so it goes from negative to positive, making an absolute minimum. Like I said, this sentence you have to know the structure of how to write it, especially for the AP exam. So it's not fun, but it's not super hard. The answer is really all in the sign chart, so you just kind of write down what the sign chart is saying, and you'll be fine. Remember, as I said, you actually have to solve the equation, or solve the question, which I added in as step number 5. The easiest equation, in my opinion, was x minus y equals 50. Okay, sorry for the pause. As you can see, y does not actually equal 25, it equals negative 25. Sorry guys, I did not realize that when I was writing. So yeah, y equals negative 25. Excuse the writing. So anyway, the numbers that you're actually finding are 25 and negative 25. Once again, I just wrote 25, excuse that. So yeah, so any optimization is really just like what we just did. We're going to do a couple more examples. You just very formulaically follow these steps, and that's how you do it. Okay, number 2, the constraint. What do you guys think the constraint is? I personally think it is whose two positive numbers whose product is 400. So that looks like xy equals 400. And the second function, the function that we're actually minimizing in this case, is the sum, so x plus y. So same thing as last time, we isolate y in the constraint and then plug it in for y in the s of x function in this case, so you get x plus 400 over x. And like I said, I write it in the way that makes it easiest to take the derivative. So that for me is to just bring that x up and make it a negative 1 exponent. Step number 2, remember, is taking the derivative and setting equal to 0. Like I said, the derivatives are really not too bad in these. Yeah. And remember, you gotta, I think I write setting equal to 0. I might not. Excuse me if I don't. So anyway, I am just kind of writing it in different forms to make it easier to set it equal to 0 and find the zeros in. So that was just me finding a common denominator and writing it as kind of one thing instead of two. And then I'm factoring up top so I can find the zeros easiest. And always remember, guys, to write equals 0. Sorry I didn't. But in this case, you find that the x's are actually plus and minus 20 as well as 0. So you might be asking yourself, wow, I don't know which 0 to focus on. There are 3 of them. What? So what I actually do is I draw the sign chart involving all 3 zeros because it's easy to draw the sign chart that way. And in this case, like I said, I'm not going to really super go into the sign charts, but it kind of looks like a W right there. It bounces at 0 because it's x squared. It's positive because the equation's positive. But the way you figure out which 0 to focus on, which is really the important thing in this case, is it says in the problem it is a positive number. So we just kind of chop that sign chart off at 0 and only look at the right of it. We only look at the positive stuff. So here comes the annoying sentence again. I'm sorry, guys. I'll fast forward me writing it, though, to make it a little more bearable. But in this case, it says, because s prime of x is less than 0 for when x is in between 0 and 20, and s prime of x is greater than 0 for when x is greater than 20, s of x will have an absolute minimum of x equals 20. That's, like I said, is important on the AP exam, but remember, you have to actually solve the question. which in this case is to find the two positive numbers whose product is 400. So, and whose sum is the minimum. Now that we know x, that's pretty easy. Plug it into either equation. I plugged into the constraint. That's normally the one that's easier for me. And so you end up getting y equals 20, because 20 times 20 is 400. A lot of the times the numbers are actually like the same number. Or one of them's negative and positive, like in example 1. All right, moving on. Number 3. Sorry if my face is in the way. I'll move it down again. Number 3. So like I said, finding the constraint and the function you're actually using. In this case, the constraint is a little more complicated, but still not too bad. Sorry for my weird underline. So in this case, the constraint is the sum of twice the first plus the second number equals 32, which is 2x plus y equals 32. Sometimes it takes a minute to translate words into algebra, but you guys can do it. And once again, we're solving for a product. So x times y. So the first step is to isolate y so you can plug it in. And a lot of these I didn't go through the step-by-step of how to isolate. I believe you guys can do that, just algebra. And then you plug that into your function, which in this case is p of x, the product. And then, like I said, I always write it in a form where it's easy to take the derivative, because that is step number 2. So p prime of x in this case equals 32 minus 4x. And remember to set that equal to 0. And then you just solve for x. So in this case, x equals 8. 4 times 8 equals 32. And 8 is that 0 in the side chart. And kind of the same explanation from problem number 1. This is kind of just a simple linear equation, and the slope in this case is negative, so it is a negative line. And if you can't really remember to do that, you know you're looking for a maximum, which, if you remember a maximum, it goes from positive to negative, which and this line goes from positive to negative. So that's how I always remembered it. Okay, number 4, the annoying sentence. Sorry guys. I'm just writing it out. So in this case, it is because p prime of x is greater than 0 for x is less than 8, and p prime of 0 is less, and p prime of x is less than 0 for x is greater than 8, p of x will have an absolute maximum at x equals 8. Mouthful, really not that hard to remember. I believe in you guys. I'm sorry it's annoying. So step number 5 is to actually solve for the question, which is the two positive numbers that you're looking for. And now that you know x, it is easy to solve for y. In this case, y equals 16, because 16 times 2 is 32. Yeah, cool. I hope I'm moving at a reasonable pace. I feel like I'm going kind of fast, but I think you guys are hopefully hanging on, at least by a thread. So number 4 is kind of a weird one, just because if you read the problem, find a positive number such that the sum of the number and its reciprocal is as small as possible. So if you think about this in math terms, you realize that there's really only one variable in here to start with. So we don't have to find a constraint to make the equation only one variable. So in this case, I just wrote the constraint, the number is positive, just to kind of keep the same formula that we've been using. And the reciprocal obviously is just 1 over whatever the number is. So that is the formula we already know. 1, you don't need, remember, because the s of x in this case is already in terms of x. So you get to skip it. You get a little less work for this one. Congratulations. Number 2. So remember, we have to find the derivative of s of x, but first I'm going to write it out in a little easier form to take the derivative of. So s prime of x in this case is 1 minus x to the negative 2, I believe. Yeah, I don't know why I wrote that 2. Yeah, cool. And then remember we have to set it equal to 0, but first I'm going to put it in a little easier form to solve the zeros in. So once again, I'm going to create a common denominator, just simple algebra stuff. Make sure to pay attention and not make a careless mistake in it because it's definitely easy to do. So like I said, I just made a common denominator and then wrote out, and then I factored out the top to make it easier to see zeros. Guys, really, I'm sorry I do such a poor job at it, but really, really do try to remember to write out equals 0. If nothing else for you, just remember what you're doing. In this case, so as you can see, x equals -1, 0, and 1. So we're going to draw out that sign chart, -1, 0, and 1. Once again, this kind of looks like a W. Bounces at 0 because of x squared. Go watch the sign chart video if you don't know what I'm talking about. But remember, once again, we're only looking for positive numbers, so we're just chopping that sign chart at 0 and only looking right. Number 4, really annoying sentence. In this case, it's because, you can literally see me reading it, because s prime of x is less than 0 for x in between 0 and 1, and s prime of x is greater than 0 for x is greater than 1, s of x will have an absolute minimum at x equals 1. Like I said, these sign charts really kind of match up with whether you're trying to minimize or maximize if you do it right. See, as small as possible, so you're looking for a minimum. Those usually line up if you're doing everything right. They always will line up if you're doing everything right. And once again, you have to actually solve the problem. So you're finding a positive number, that the sum of the number and its reciprocal is small as possible, and x equals 1, and that's that number. So you're all good. All right, moving on to the back, halfway there, guys. Number 5. So the back page is kind of more of a practical applications of optimization. It's finding the perimeters and the areas and all of this stuff that actually is kind of useful when you're thinking about it. But also just, it's still very easy. Just keep in mind of what the question is really asking. So the constraint of finding the dimensions of a rectangle with a perimeter 64. So the perimeter 64 is the constraint. And you just kind of have to logically think through what that actually means. So a perimeter is 4 sides, 2 are the same size, and then the other 2 are the same size. So it's 2x plus 2y equals 64. And then the area is large as possible. And that, remember, as you know, is xy, base times height. So that is a product. Number 1, remember, we're going to isolate y in the constraint, so that we can have one variable in a of x. So I just wrote out the constraint, and then I think let's see. And then I just solve for y. This arrow doesn't mean anything. It's 100% my own notation, so you can just kind of ignore that if you want to. This is just showing that I rewrote the constraint in terms of y, like I've been doing the whole time. I don't know why I wrote it differently this time. And so now we plug in 32 minus x for y into the constraint, or 32 minus x, excuse me. And once again, I'm just going to write it out to where it's a little bit easier to take the derivative of, because that is step 2. You're going to find a prime of x, which in this case is 32 minus 2x, if I can do my math right. And look, you set it equal to 0. I wrote it. Okay. So you find that x equals 16. Hopefully you guys know by now that step number 3 is drawing the sign chart. The 0 in this case is 16. The slope in this case is negative because of, stupid hand, because of this -2, y equals mx plus b. -2 is m, so it has a negative slope. And then number 4 comes the annoying sentence. I'm sorry, guys. but you're just going to have to bear with me. In this case, it is because a prime of x is greater than 0 for x is less than 16, and a prime of 0 is less than 0 for x is greater than 16, a of x will have an absolute maximum at x equals 16. I'm sorry if I said one of those wrong. I might have. I'm reading it off the sheet just because it's easier, but I hope you can see where that's coming from in the sign chart. As you can see, a prime of x is greater than 0 for a is less than 16, yes, and a prime of 0 is less than 0 for x is greater than 16. I'm literally just writing out what the sign chart says. And number 5, you actually have to answer the question, which in this case you're looking for the dimensions of this rectangle. So you know that 2x plus 2y equals 64, and you know x now, so 2 times 16 plus 2y equals 64, some algebra or hopefully calculator, and you will find that y equals 16 as well. So the dimensions of this rectangle, actually a square, is 16 by 16. Cool. All right, 3 more, guys. I believe in us. Okay, number 6. Find the dimensions of a rectangle with an area 400 square meters whose perimeter is small as possible. So this is kind of just flip-flopped. We know the area, we're looking for the perimeter. So in this case, the constraint, remember what area means, is just base times height, x times y, so xy equals 400. And then the perimeter, which I call p of x for perimeter, is once again 2x plus 2y. So hopefully you guys know by now you have to isolate one of the variables to make sure that p of x only has one variable. I always isolate y. You get 400 over x. It looks familiar. 2x plus 2 times 400 over x is what p of x turns out to be. And then once again, I write it in a way that is easier to take the derivative of, because that's what you're doing next. Hopefully you guys know that. I don't know why I don't keep writing it on. Okay, there we go. Yeah. 800 times x to the negative 1. So step number 2, finding p prime of x. In this case is 2 minus 800x to the negative 2. And I do some algebra to manipulate it into one fraction that is easy to find the zeros of. I wrote it out for you guys, so you can follow along if you need help with algebra. So hopefully it'll be, I'm not going to say everything out loud because you guys can read it if my stupid hand's not in the way, I swear. And so you end up getting 2 times x plus 20 times x minus 20 over x squared, which is easy to find the zeros of, and the zeros end up being negative 20, 0, and 20. Also, once again, trying to remember to write equals 0. I'm sorry I do such a poor job of that throughout the video. Number 3, finding the sign chart. Once again, looks like a W. The function's positive, so that's why it's a positive parabola, and it bounces at 0 because it's squared. Watch the sign chart video if you're confused what I'm talking about. And you might be asking yourself, how do you know which 0 to focus on? But this is kind of like a logical thing. You can't really have a negative area or a negative length or even a length of 0. I don't know if I write it out in the video. I think I do, but once again, we're going to chop it off at 0 and only look to the right so that we can only focus on the x equals 20, because that is the only logical 0 that would make sense in this case. And then once again, I'm going to write out the stupid sentence. Sorry, it's not stupid, but you just have to know it. In this case, it's because p prime of x is less than 0 for x is in between 0 and 20, and p prime of x is greater than 0 for x is greater than 20. P of x will have an absolute minimum at x equals 20. Once again, just saying exactly what the sign chart says. So I believe in you guys. And then we actually have, oh look, I did do a little chop right there. And then you actually have to solve for the dimensions. You have to answer the question. You know, xy equals 400, and I think this has literally been another problem on the worksheet. You figure out that y also equals 20. So the dimensions, once again, is a square, is 20 by 20. Good job, guys. All right, number 7. This one is slightly more complicated. So a farmer has 800 feet of fencing and wants to fence off a rectangular field that borders a straight river. He doesn't need a fence along the river. So what are the dimensions that have the largest area? So you have to think about what the constraint is in this case. So what all does he need a fence for? What does that equation look like? So what actually helps me is drawing even a little picture. I know it's cheesy, but it helps. So it borders a straight river. So, and he doesn't need the fence along that river, like I said. So just draw a little river on one of the sides, and remember that you don't need to include that in the perimeter equation. So the constraint in this case is 2x plus y equals 0. And I'll explain that. Equals 800, excuse me. So I drew the river on the y side to make this a little bit easier for myself. So 2x, so both of the x lengths are there. You need the perimeter. You need the fencing for both x lengths, so there's 2x, but you only need the fencing for one of the y sides because there's a river on this side, so there's only one y. So you get 2x plus y equals 800. The constraint, it's area, it's looking for the inside of the rectangle, which is just x times y. That does not change with the weird constraint. So, constraint, once again, we're isolating y, and then we are plugging that y into the y for a of x. So you get x times 800 minus 2x. And once again, I'm going to write that out so that it's the easiest to take the derivative of, because step number 2 is finding a prime of x and setting it equal to 0. I hope I remember to write it on this one. Do I? I sure do. Okay, so there's only one 0 in this case, 200. So our 0 in our sign chart equals 200. And it's a negative slope because y equals mx plus b. Ooh, my hand's in the way. M is -4, which is negative. And we're once again back on the sentence, which in this case is because a prime of x is greater than 0 for x is less than 200, and a prime of x is less than 0 for x is greater than 200, it will have a of x will have an absolute maximum at x equals 200. I'm just writing out literally what the sign chart says. So I know it's tedious, but it's a really good thing to know, especially for the AP Calculus exam. And step number 5, you actually have to find the dimensions of the field. You have to answer the question. So I always use the constraint to solve for y. You can definitely use a of I guess you have to use the constraint. And you just solve for y. You get 400. So in this case, it actually is a rectangle, and the dimensions are 200 by 400 feet. Yep. So once you really figure out the constraint and the second equation, everything is pretty much exactly the same, doing the exact same steps. Just figuring out what the constraint can be sometimes is confusing. This one's also a little bit confusing. So if 48 square centimeters of material is available to make a box with a square base and an open top, find the largest possible volume. So, I'm going to try and draw this box. It is really not great, but I hope it helps you a little bit to visualize. If things are tricky, just draw them out, and I promise it'll help. So it's a square base, so both of the length and width of the base are x, and then the height of the box is not, we don't know what the height of the box is, so I labeled it y. So you have to think about what all sides we need to cover with material. There's an open top, so we don't need that. We don't need material on that side. So, the constraint. I'll write it out and then explain it. Okay, so x squared plus 4xy equals 48. So, I will start with the x squared. The x squared comes from the base of the box. Since it's a square base, we know that both sides are the same length, and the area of this base is base times height, or length times width, and they're both the same, so it ends up being x squared. This square at the bottom. 4xy comes from the four sides of the box. You need to find the area of these four rectangles, which are the same size, and cover them with the material. And once again, the area of a rectangle is base times height, which in this case is x times y. So you get 4xy. The open top, if it were a closed top, it would be 2x squared. But since it's an open top, you don't need the material to cover this x squared square right here. So we don't include it. And then we're finding the volume. So I signify that by v of x, and the volume of this box is x squared y, because a volume of a rectangular prism is base times height, base times length times height, x, y, z. But in this case, two of the lengths are the same side, are the same length. They're both x, so you can really just do x squared y. Okay, now that is definitely the hardest part of optimization and of this problem. So now that we're on to step 1, writing out the constraint in terms of y, so you can plug it into the equation, the second equation, and only have x to deal with. And then I actually explained how I got y to do that, how I isolated y. Sorry, I'm just speaking gibberish right now. I actually explained how I isolated y in case you guys got a little bit confused with the algebra. So now I'm plugging in that mess for the y in the equation, and I am going to write it out a little bit easier so that I can take the derivative of it. And actually do it in a lot of steps that I'm going to write out for you guys so that it'll be a little bit easier to see. I'm going to fast forward it, and then you guys can pause it once I write everything out if you need help with the algebra. Okay. So now we are on to finding taking the derivative of v of x, and then setting that equal to 0. And that's a 2 if you can't read that. Sorry, it's bad. And once again, I'm going to write it out as in an easier form to find the zeros of. And once again, I'm going to write it out in case you guys need help with that manipulation in algebra. Okay, I will explain this step. Oh, my hand will get out of the way. Okay, you can read it. There we go. So, as you can see, it was 16 minus x squared, and then I took out a negative 3, so it'd be x squared minus 16. If you take out a negative, it'll flip those two flip the x squared and the 16. I always like having the variable first, so that is why that negative is there. Okay, I'll move myself out of the way so we can see. And so the x's end up being positive and negative 4. So now we're going to draw the sign chart with those two numbers. Like I said, if you don't understand sign charts, make sure to watch the sign chart video, but in this case it's a negative parabola. It's a parabola because it's an even number of x's, and it's negative because of this negative right here. Cool. Okay, and once again, this is kind of just a logical thing. Can't really have a negative 4 inches or centimeters, so we really just lop it off at 0 because sides have to be a positive length. And then we're on to, so 4 is the 0 we're going to focus on, is basically what I'm saying. And so now we're writing out the annoying sentence again, because v prime of x is greater than 0 for x is in between 0 and 4, and v prime of x is less than 0 for x is greater than 4, v of x will have an absolute maximum at x equals 4. Oh, sorry, you guys can't read it. There. Once again, I'm just writing out what the sign chart is saying. Y'all can do that. And then last step of the last problem, we actually have to answer the question. We have to find the largest possible volume. In order to do that, we have to solve for y first. So let's plug in 4 into the constraint and solve for y. And then we have to find the volume, and remember the volume equation is x squared y. So now that we have x and y, we know that that is 4 squared times 2 equals 32. Okay, that is it. Thank you guys for watching. I hope it was helpful. Really just keep in mind, sorry, I thought I had something to tell you guys. I guess I didn't have something to tell you guys. But just remember, for AP Calc, this annoying sentence that I've been referencing, number 4, you do have to know how to do. Always remember to do step number 5 and actually answer the equation. And always remember that if you can logically think through the constraint and the second equation, you will be able to do this. I believe in you guys. Thanks for watching. I hope it was helpful. And be sure to tune in next time. Bye.